Hi guys, Unit 7, Section 3. Adding and subtracting radical expressions. So we're going to add and subtract radical expressions. Okay, again, we're just simplifying, but this is another way of simplifying radicals. Okay, the first thing that you have to remember, and this is the big idea here, is you must have the same number variable or term under the radical. This is like adding or subtracting like terms. And I'm going to show you the difference in the first two examples, what I mean here. Okay, so let's get to a couple of examples. I'm going to show you one that's an example and one that doesn't work. You can't add them. Okay, so let's look at the first one. If we have 4 roots of 3, and we have 2 roots of 3, we look and see under the radical, is everything exactly the same? And it is. We have a 3 under both. And we add the numbers out front. So we have 4 roots 3, and we have 2 roots of 3. So that means we have 6 root of 3, because 4 plus 2 is 6. And then the root 3 is just kind of like having an x or a y on there. We don't change that. We don't mess with it. We're just seeing what's alike and we're putting them together. Now that works, but if you look at this one, number 2, 5 root 2 plus 4 root 3. You can't do anything with these. You can't add a root 2 and a root 3 together. They're not the same. I'll refer back to my weird example. They're not the same prisons. You can't put them together. You can't put these groups together when we add. And so this would just stay 5 root 2 plus 4 root 3 because they're not the same thing. We can't add them together. So that's the simplified for that one. And for number 1, it's 6 root 3. So if you kind of look at the difference there, and we're going to go through a couple of these, okay? So let's look at number 3. If we have 7 root 2, and we're going to take away 8 root 2, the root 2 is the same in both, so really what we're doing is 7 minus 8, which is negative 1 root 2. Or if you want to be fancy, you could just put negative root 2. And that would be the answer for number 3, simplified. Now let's get a little more complicated, okay? Number 4, we have a root 5 plus a root 2 minus a 3 root 5 plus a 5 root 2. Now this is very similar to putting together like terms. That's exactly what we're doing. So I'm going to look at the root 5 and I'm going to see if there's anything else that has a root 5. And we have negative 3 root 5. Well, this is where that invisible 1 comes into play. You got to always remember this in front of that root 5 is that invisible 1 that mathematicians don't like to write. So maybe you want to make it visible and say that 1 minus 3 is negative 2. And what were we counting? We were counting root 5s. Okay? And then I'm going to look and see at my root 2s. Are there any root 2s that can be combined? Well, I have a 1 root 2 and a 5 root 2. As long as the root and the 2 are the same, we can add them up. Again, we have an invisible 1 in front of this one. So we have a 1 root 2 plus a 5 root 2. And so that's going to give us a 6 root 2. And so our final answer here would be negative 2 root 5 and plus 6 root 2. Now if you wrote 6 root 2 plus negative 2 root 5 or minus 2 root 5, that means the same thing. It's commutative property of addition. We could switch the order, just make sure the negative is still in front of the 2 root 5. Okay? All right, now let's look at one that has some letters in it, number 5. Number 5 is root 5x minus root 3y plus root 2x plus 4 root 3y. Okay, let's talk about what's the same here. So I just start on the left and I start looking for anything that can be combined. So in this case, we have a 1 root 5x. There's a root 2x, but there's no root 5x. So root 5x cannot be combined with anything. So that's root 5x goes there. Okay? And then I'm going to look at a negative root 3y, and there is another root 3y, and there's a 4 in front of it. Now remember that negative root 3y is actually a negative 1 there. Okay? So negative 1 plus 4 is 3, and then we were counting up how many root 3y's we have. So it's 3 root 3y. Okay, and then I still had something left in this problem, and that's that root 2x. Well, there's nothing that can go with that root 2x because it has to be exactly the same. And so that's just plus root 2x. So our final answer here is root 5x plus 3 root 3y plus root 2x. Again, we're not really getting an answer. We're just simplifying. And so that's what's going on here. Okay, we're simplifying. Now, sometimes, that was just 1 through 5. Now I want to talk about, sometimes you have to simplify first from what we learned in section 1 and section 2, and then add subtract. So we're going to do a couple examples of those. So let's continue with the same numbering system. So let's look at number 6. 2 root 18 plus 3 root 2. Well, at first glance, they don't go together because you have a root 18 and a root 2. But then I start thinking about that root 18, and it doesn't look like it's been prime factored. And so that means that radical is not in simplified radical form. So before we can write an answer, we have to make sure that's in simplified radical form. So I'm going to go through what we did in section 1 and 2, and I'm going to prime factor 18. So that's 2 times 3 times 3, and then I'm just going to put plus 3 root 2 over here for now. Okay? And then I'm going to look at 2 root 2 times 3 times 3, and I'm going to see if there's any jailbreaks that can happen. And in this case, 3 times 3 can come out. Now remember, the 2 on the outside, just kind of waiting for any escapees. Something terrible happens, only one of them gets out. And then we have the root 2 plus 3 root 2. So what we have right now is 2 times 3 root 2 plus 3 root 2. Well, what's 2 times 3 on the outside? That's 6 root 2. And now we do have the same radicals. They're both root 2. So we can actually simplify this down all the way to 9 root 2. But like I said, at first glance, it didn't look like they went together. So you have to simplify first, and then you can see if they can be added. They can't always, but sometimes they can. Let's go to number 7. So if I have a root 12 plus a root 75, they do not go together. They don't have the same thing under each. But before you write the answer in the blank, you need to make sure they're both in simplified radical form. So 12 can be prime factored to 2 times 2 times 3. And 75 can be prime factored to 5 times 5 times 3. Now I'm doing that quickly. You might want to pause between those two and start saying, can I prime factor that quickly? Do I know what the simplified radical form is of each? Okay, in this first one, the 2's can escape in the first radical. So we had a radical 2 times 2 times 3. In that case, the 2's come outside the radical. So we have 2 radical 3 plus in the second term, we have a radical 5 times 5 times 3. So the 5's can escape, and that gives us a 5 root 3. Of course, shockingly, look what happened. Now we have the same radical. And so we can add the front numbers. And so this will be 7 root 3 for number 7. Okay, let's do one that has variables in it. So let's look at number 8. 4 root a squared b minus 3a root b. Again, looking at this at first, it appears that there's no way to add these together. But I also notice that I have an a squared up here. So I need to take my first radical, the 4 root a squared b, and I need to simplify that. Now you don't have to write out this step, but I'm just going to show you. I took a squared and I wrote a times b. And then the second term was 3a root b. There's nothing I can simplify there. So if I look at that first term, there are 2 a's under the radical, which means we can have a number escape. So the a's escape, only one make it out. So we have 4a radical b minus 3a radical b. Now this is a little confusing, and I wanted to show you this one because we have a's in front and b's on the inside. If we're dealing with variables, the letter on the outside has to match the letter on the outside of the second one, and the letter on the insides have to match. So we have 4a root b minus 3a root b, and so that's going to be 1a root b. You can leave it like that, or you could put a root b. Either way, that's how you're going to deal with the variables in the problem, okay? See what you can do with that. Again, stop by Google Meets if you're having trouble, and we'll go over some more if you need to.